Hi everyone. So this is about your problem set 4. The first problem is you're given two vectors. X vector is 3I cap plus 3j cap plus 0 k cap, and y vector is I cap plus 0j cap sorry plus 0 k cap. So you have to find angle between them. I think you know this formula that cos theta is basically dot product of these vectors, right? So what you will have, x vector dot y vector divided by norm of these vectors, right? No, basically just you have to evaluate these things. So what you will get on tau, 3 into 1 plus 0 into 3 plus 0 into 0, right? The norm will be 3 square plus 3 square plus 0 square, right? Multiplied by 1 square plus 0 square plus 0 square. So what is it, guys? So this is 3 by 339. So that is 18, right? So what is 18 if you see? 18 is 6 into 3, right? And what is this? This is 3 square into 2, correct? So what you will get here is this is 3 divided by 3 root 2, right? This is 1 upon root 2. And you know, when cos theta is 1 upon root 2, when the theta is pi by 4. Yeah, well, you have other values also, but when you are talking about angle between the two vectors, you are talking a value between 0 to 2 pi, right? I'm sorry, I have a little bit of cough today. Sinus things. Okay, that's what you have to do. Second, so you have to find the equation of plane which passes through the point 6 comma 1 comma 1 and which is orthogonal to I cap plus j cap plus k cap. I hope you remember the idea. So what were the idea, guys? So say you have a plane which is you have some point here. Say this is in particular 6 comma 1 comma 1, and you have some arbitrary point. Take some arbitrary point. And you have this vector hanging, right? What is this vector? This is orthogonal. So I cap plus j cap plus k cap. Basically component wise 1 comma 1 comma 1, right? So since this is orthogonal, so this will be orthogonal to this vector also, right? What I mean is vector, how, I don't know how you write it. We can call it say B. This is say A and B. So vector AB is orthogonal to oh sorry, I have called it B, so I can call it C, say for example. C vector, right? So what you will get is x minus 6, comma, y minus 1, comma, z minus 1. This vector is orthogonal, meaning dot product is 0, right? Orthogonal means 90-degree angle. So cos 90 is 0, right? So what you have here is 1, comma 1, comma 1. Yeah, this is equal to 0. So what you have is x minus 6 plus y minus 1 plus z minus 1 is equals to 0. So in other words, you have x plus 5 plus z equal to what? 8. So this is your equation of plane. That's all. Okay, and x, y, z are in R, or the vector x, y, z is in R3, which lies on this particular plane. Okay, and the third problem is you have to find the equation of plane passing through. 1 comma 0 comma 0, 4 comma 2 comma 0, and 3 comma 2 comma 1. Now guys, what you have to do? You can call this A, you can call this B, and you can call this C. Now you can have equation of, a plane if you have an orthogonal to it and a point line on it. So can you find orthogonal? Yes, you can, right? So you have this situation. Somewhere you have this 1 0 0. I don't know, I'm just randomly plotting, okay? Somewhere you have 4 2 0, and somewhere you have 3 2 1. You take this vector and say you take this vector. Okay? You know an operation called cross product, right? What it gives you? It gives you a vector which is orthogonal to both of them, right? So let us compute these things. So what will be a b vector? This is nothing but 3 comma 2 comma 0, right? We are avoiding that ijk. It's always I'm very lazy to write. And what will be a c vector, guys? It will be 2 comma 2 comma 1. Now you know how to do the cross project. So the cross product is a vector like this, which will be given by this your I cap, j cap, k cap, and you write your vectors 3 2 0, 2 2 1, like this. The determinant of this. So what it would be? So for the corresponding to the I cap, you will have 2. Corresponding to the j cap, you will have minus 3, and corresponding to the k cap, you will have 3 into 2, 6, 6 minus 4, that is 2. So this is the vector which is orthogonal. Now you have a vector which is, a vector, a point on the plane. You can take any one of them, like, for example, you can take 1 comma 0 comma 0, that's also fine. Or you can take 3 2 1, whatever the choice of point you want to take. And you have a vector orthogonal to it. Now it reduces to the first problem, right? So this is your vector which your plane is orthogonal to, and take any point, say 4 comma 2 comma 0 if you take, and then you can find the equation of plane, right? So if you take point to be 4 comma 2 comma 0 and vector to be this 2 comma, you know what will be the equation of plane. X minus 4 into 2 plus minus 3 into y minus 2 plus 2 into z equal to 0. This is 2, yeah, it looks like that. That's why I made z like that, whatever you call cursive or whatever. This is the equation of plane. That's all you have to do. And you can solve this like the first case. Okay, good. Now you have another problem. What is the another problem you have? So you have given a function from R3 to R3, and I'm sorry guys. So how you are defining it? F of x1, x2, x3. This is basically this vector 6 comma 3 comma minus 5 cross product with the vector. I'm avoiding the suffixes I, j, k. X, y, z. So what will be this, guys? You can obtain it from this determinant, right? I, j, k, cap, cap, cap. And say you have 6, 3 minus 5, x, y, z. You have to worry about the order, right? Otherwise, it give you the minus of that sign, right? So you have to write, you cannot write x, y, z on top. Okay. So corresponding to the I, what you will get is 3z plus 5y. Okay, very nice. corresponding to j, you will get 6z plus 5x. And corresponding to o, I mean minus of that. And corresponding to the k cap, you will get 6y minus 3x. Well, what you have been asked is to show or to check if this function is continuous, right? So let us see. So for continuity, what you have to do, guys, you have to apply the definition or some results. I will not use any results because you haven't been taught of those results. So I will use the definition. So continuous at arbitrary point you have to show, okay? So let or maybe prove that result for these people are using. Um, no, let us do it directly. I don't know. Just give me a time. Give me some time. Okay, we will prove the result. So let f from Rn to Rn result. So actually they are using this result. And I don't know if you have done in class or not. They are using as in your assignment sheet. So we will prove this result. So let f from Rm to Rm be a function. That is, it is something like this. f1, f2, dot, fm, where fi's are what? Function from Rn to R. That's how it will be, no? So if you have some x1, x2, dot, xn, it will be applied to all of these. x1, xn, f2, x1, x2, xn, comma, dot, f of m, x1, x2, dot, xn. That's all, right? Now, what is the claim? Then, result, or you can call it even theorem. F is continuous if and only if fi's are continuous. Anyway, you will be using this result in the reverse direction. So let us prove the reverse direction. So reverse direction. So let fi's are continuous. And you have to show that f is continuous. So let epsilon bigger than 0 be arbitrary. How we show a function is continuous? I always told you or have tell you to write like this property, right? What you have to show to show. So take any arbitrary point, right? So a1 up to an and rn. We will show that it is continuous at this point, meaning it is continuous everywhere. So to show, what we have to show, there exists a delta bigger than 0 such that whenever you take this norm of x1, meaning Euclidean distance, a1, an, whenever the distance between these 2 points is less than delta, and this is bigger than 0, this should imply, oh, we are doing continuous. So no need to have this. Norm of, now you don't have mod here, right? Of f is a function from Rm to Rn. So distance of, these points. This should be less than epsilon, right? That's what you have to do. Now your epsilon is arbitrary and you have given that fi's are continuous. So let us proceed. Since fi's are continuous, so there exists delta 1, delta 2, dot, delta n bigger than, how many are this? M bigger than 0 such that something will happen, right? What will be that something? Such that modulus of, you see, fi's are function from where to where? Fi's are function from Rn to Rm. Xn minus fi of a1 an. This modulus will be less than epsilon for every x1 up to xn, such that the distance, right? Okay, you can write distance now in the definition of the distance way, such that the distance of x with the point a1 a2 an. So what it will be, x1 minus a1 square plus dot 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 xn mn minus an square is less than delta. That's what we have given, right? This is for every I this is happening, right? Okay. So let us call this delta, by the way, I, for every I from 1 to dot 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 m. Now you have various deltas. What you always do, you choose minimum of these, right? So choose delta to be minimum of delta 1, delta 2, dot dot dot, delta m. Now what you have, if this hold for every delta like this, so these all of them will hold for. So can I call this x and can I call this a? That would be easy to write. Is always less than what? Epsilon whenever your distance, which is x1 minus a1 whole square plus dot 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 xn minus an whole square is less than delta. Right? Okay, for all such x. Now you have this, call it star. And this is happening for every I in 1 to m. Okay. Now what you have to do? You have to show the distance of these 2 points, right? Here. So let us show this. So consider norm of f of x1 xn. Shall I write it x only? Minus f of a. So what it is, guys? It is the distance of these 2 points. If you see carefully. So it's everything is happening under root, right? So better to consider square because then we can handle it easily. So f1x, fmx, distance of these 2 points, right? fm at a, fm at a, square. So this will be, this will be f1x minus f1a whole square plus f2x minus f2a whole square plus dot dot dot. What you will have here? fmx minus fma, this whole square. Basically, it's whole square, so it's mod. Now you can use star, right? By star. By star, this is less than epsilon square. How many times? And m times, right? This is m epsilon square whenever, what will happen, guys? Whenever under root of x1 minus a1 whole square plus dot 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 xn minus an whole square, this is less than delta. Correct? I have used all of these statistics. Now, this will implies norm of fx, comma, or minus, whatever you want to write. Basically, I mean, the distance is what? This is I can remove the square. This will be less than under root m epsilon, right? Okay, whenever this thing happens. Now you have to do the small manipulation, right? Rather than this epsilon, what you will do is, let's do it with a different color, epsilon by root m. Epsilon by root m. Because you can do m is non-zero, right? So since fi is continuous for epsilon by root m bigger than 0, there will be some deltas. That will be the change, right? Because here then you will have m and here you will have under root m. This will get eliminated and you will get it epsilon. Oh, well, that's what you have to show, right? So this implies f is continuous at your point A, which is a1 up to an, in Rn. And this point was arbitrary, so you are done. So f is continuous. So you see, if f is continuous, then you can always show, sorry, that, if fi's are continuous, then you can always show that f is continuous. Reverse is also true. So now let's do the reverse direction. So let f is continuous. To show fi's are continuous. So let epsilon bigger than 0 be arbitrary. I'm not writing what you have to show, now you know, right? So since f is continuous, what will happen, guys? This will imply, what this will imply is, there is a delta bigger than 0 such that the distance of fx minus fa, so you have to choose arbitrary point, right? Let a equal to some a1 up to an belongs to Rn is less than epsilon whenever, you know, norm of x minus a is less than delta, meaning Euclidean distance. So this will implies, write it like that. Fix, sorry, f1x minus f1a whole square plus f2x minus f2a whole square plus dot 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 f, what? M, right? X minus fma whole square is in fact less than epsilon. So whenever or for all x such that norm of x minus a is less than beta. Of course, x is the member of, this r of, r of n. Just let me take my medicine. Okay, well, if this is the case, observe one thing. This will implies, okay, let me tell you like this. So if you have something like this, so you know this, right? Mod a1 is always less than equal to mod a1 square plus mod a2 square. In fact, mod a2 square is always less than equal to mod a1 square plus mod a2 square. That's what we will use here. So what you will get in particular here, all of this fix mod minus fia, this will be less than or equal to this whole square root thing, and which is further less than epsilon, and this is same for every x as that norm of x. Oh well, this is the definition, right? So this implies fi's are continuous at a in Rn. Note that you have chosen that a to be arbitrary element, right? So, in particular, fi's are continuous. So, this is the result which you will use here, and that is how the question is done in your solutions. So, what you have again, let's copy the function. Control C, right? Hmm. So, you have, so this is what you have, right? I hope I hadn't made any calculation mistakes. Now, you can clearly see that f1 of x1, x2, x3, which is 3z plus 5y, even you can use your epsilon delta, but this you have done, so no issues. Sorry, not 65x, 5x. I'm taking x1, x2, x3, and I'm writing coordinates as, huh, you know, x, y, z. So let me change it. So this will be x, y, z. X, Y, Z. Sorry for this silly thing. This happens when you are very tired, and which I am. So, x, y, z, x, y, z, x, y, z, x, y, z. And this kind of questions you have clearly shown in the first half or the starting of the semester. So FIs are continuous. So if FIs are continuous and being polynomial functions, you can also say like that. So this will imply that F is continuous by above result. So you need to prove that result. You cannot assume such a beautiful result, just like that. And you have to have that result in your mind. Okay. I didn't know that if it has been proved in class or not. That's why I discussed in the tutorial or the, whatever this video. Okay. Now you have the question on that Lagrange multiplier thing. So let us have the first question, question fifth. So we have to find the points on the sphere which are farthest or the closest from the given point 3 comma 1 comma 3 comma 1 comma minus 1. So how you do? You take any point on sphere, right? Let x comma y comma z be arbitrary point on g x y z equal to or on graph or I should not say graph. Let me just write the full thing. Okay. Now, it's I should say level set there if I'm writing in that language. Okay. Be arbitrary point, right? So you know what is the distance between them is under root x minus 3 whole square plus y minus 1 whole square plus z plus 1 whole square. See, rather than maximizing or minimizing, teachers maximize or minimize this square will be one and the same thing, right? Because that will simplify your calculation. Yeah, I know I haven't done it before. I just wanted to make you realize that, oh, I am doing it in a very long way. You can do it in some shorter way. Okay, so this is your function, say f x y z, and you have to minimize with respect to this constraint. What your Lagrange's theorem says, if at all the minima exist at some point, then you should have such this kind of equation at that point, right? That fx of x comma y comma z should must be lambda of g, or maybe let's write in the gradient manner. Gradient of f should be same as gradient of or nabla of this g x y z. That is what your Lagrange's theorem says. If x, y, comma, z is the point of minimum or maximum, then it has to satisfy this equation. So what we will do, we will consider this and solve it for the value of x, y, z, and at all those points, whatever we will get, we will evaluate the situation and see what's happening. So see, now it becomes so simple using Lagrange multiplier, right? So what it would be? So basically you can do it on curves like that. Curves, I should not say, or the surfaces. Basically the equations like that, gxyz equal to something. Okay, basically the kind of boundary set, not the open kind of things. Okay, so what is it? Nabla of this is this. So meaning, let us calculate. So partial derivative of f with respect to x, that is 2x minus 3. And with respect to y, with respect to z, this should be same as lambda times 2x, 2y, 2z. Now you have the conditions, right? So 2 to 2 you can eliminate. You compare the coefficient, you will get x minus 3 is equals to lambda x. And you will get, what you will get? This y minus 1 is equals to lambda y, and furthermore z plus 1 is equals to lambda z. Now see, there are, two ways to do these things. Either you eliminate lambda, or just a second, I have to see this message. Sorry for the disturbance. Yeah. So either you have to eliminate the lambda to find xyz, or you may find the value of lambda and then you can find xyz, right? There are the only two ways. So let us solve this further. So what it will give you, x1 minus lambda is 3, right? And y 1 minus lambda is equal to 1. I'm just taking this side and taking the common and taking the number that side. So like this, z minus lambda z is equals to 1. So z1 minus lambda is equals to what, guys? This is equal to minus 1, correct? Now what you can do, guys, from here, think for a moment, then I can give you the answer. See, note that this xyz is a point where? This xyz is a point on sphere. xyz is a point on sphere, right? It's where you are maximizing or minimizing, right? So what it should satisfy, that x square plus y square plus z square equal to what sphere you are taking? 4. So do that. What you will get from here? Square the sides. Equal to 9. Y square 1 minus lambda square equal to 1. Z square 1 minus lambda square equal to 1. Add all the equations. What you will get? X square plus y square plus z square multiplied by 1 minus lambda whole square. This is 9 plus 1. This is 11, right? And oh my god, this will be the calculation would be like something like that. Oh my god, what happens? Just a second. Oh, yeah. So it will be what 4, right? 4, 1 minus lambda whole square is equals to 11. This will implies that 1 minus lambda whole square is nothing but 11 by 4. Now you have the two possible values of lambda from here, right? So what are the two possible values of lambda? So one is 1 minus lambda minus 11 by 4. And this, if you factorize this, 1 minus lambda plus 11 by 4 equal to 0. So what it will give you guys? So it is 1 minus 11 by 4, meaning minus lambda 11 you have to subtract 4. What you will get? So 7, right? Am I right or not? I'm very, bad at calculations. Oh, by the way, this is root 11 by 2. I'm sorry. See? So one is what? 1 minus lambda plus under root 11 by 4. And another is 1 minus lambda minus under root 11 by, oh, sorry, not 4, 2. I'm using a square minus b square is a plus b minus b. Sorry for bad calculations. Now, what you will get from here, guys, is lambda is equals to 1 plus root 11 by 2, or lambda is equals to 1 minus under root 11 by 2. So you have two possible values of lambda. When you have possible values of lambda, you can find the value of these also xyz using this equation, which I am copying right now. Oh my god, this is a bad copy. So let me copy it properly. Yeah, I think this is better. Hmm. So you have this equal to, it was I think minus 1. Now, just you have to substitute the value of lambda there, and if you see 1 and 1, this will cancel out. So if you substitute the first value, you will get, so x is equals to, if you substitute this one, see 1 and 1 will be cancelled and it will be minus 6 by under root 11. And y is equals to, if similarly, right? 1 and 1 will get cancelled. It will be minus 2 by under root 11. And z is equals to, you can see it will be plus 2 by under root 11. And if you substitute, so one point is minus 6 by under root 11, minus 2 by under root 11, and 2 by under root 11. And another point will be, guys, you have to substitute this value. So when you will get it, so you will get 6 by under root 11, 2 by under root 11, minus 2 by under root 11. So you get two critical points, right? Now you just have to evaluate the value of, this f at that. So compute f at above points. I'm not doing that. Or maybe I can do that. Ah, no, I'm very lazy to do that. So compute that. Whichever will be bigger, it will be your point will be, which will be the farthest from the given point. Whichever will be the smaller, it will be the point which will be the, minimum of that function, which will be at the least distance from the given point. I hope these calculations you can do. Okay, so let us have next problem. So fx comma y is x square plus 2y square on the disk x comma y such that x square plus y square is less than equal to 1. So this is not some gxy, right? It's so again you have to split it in two parts like we always do. So case 1, when x comma y belongs to this x comma y, the open disk. Here you can use your usual double derivative thing. So what is f suffix x guys? That is 2x. What is f suffix y guys? That is 4y. So what will be your critical point when both of them vanishes, meaning x comma y equal to 0 comma 0. Okay, well, f at that point is 0 comma 0. And let us calculate fxx. What is fxx? 2. What is fyy? 4. And what is your fxy? That is 0. So it means your discriminant at this point 0 comma 0 is nothing but 8, which is bigger than 0. Right? Now you can conclude whether it is the point of maxima, minima, or a saddle point. You know the result, right? Write the final answer here. I mean, for the case, whether it is a point of local minima, local maxima, or a saddle point. Okay, case 2. That's the one where we can use actually a Lagrange multiplier now. You see, the calculations will become easy when you use this method of Lagrange's. You might have seen my solution in remedial classes. I have done a similar problem using the classical method of, finding using this double derivative test, and you have seen it as a little bit long. But now it won't be. So gxy is x square plus y square minus 1. So subject to this, you have to, whatever, you have to find the extreme values. So now you know gradient of f should be lambda times gradient of g. So what is fx guys? We have figured it out, right? Let me do it again. 2x and this is 4y. And lambda times this is 2x, 2y. Well, if you compare the coefficients, you will get lambda equal to 1 from the yeah. So it will be 2x equal to lambda 2x. Okay. And what you will have otherwise, this will be 4y, right? I think I have copied the function correctly. Let me see. Yeah, it's correct. Now, and what else you have? This 4y is equals to lambda into 2y. So what you have here is x equal to lambda x and y equal to, sorry. Yeah, that was fine. So this is what? 4, you can do 2y is equals to lambda y. Now, guys, here is the thing. You should have always this condition that x comma y lies on this, circle. So what you should have x square plus y square equal to 1. So if you try to do from here, so this will give you lambda square x square plus, y, if you do lambda square by 2 plus, this y square. This will be like, the problem is, you cannot, how to say, you cannot basically take this thing, sort of common, right? So how to proceed then, right? Because this will not give you any simple value of lambda, right? So you have to do some more analysis. So note one. X cannot be 0 and Y cannot be 0 is not possible. Why it's not possible, guys? Because if it is the case, say it is the case that both are non-zero, then x equal to lambda x will implies lambda equal to 1 and 2y equal to lambda y will implies lambda equal to 2. Oh, well, this is not possible. It cannot take at the same time two different values. A number cannot take. So what is your case? So this will implies x is 0 or y is 0. So if x equal to 0, let us see what happens. So if x equal to 0, this will implies you will have, I should write it better. No, that's fine. So this implies you will have 2y equal to lambda y. This is the equation which you should consider because that equation won't give you anything. So if y is 0, okay, 0 comma 0 does not lie on circle. So if it doesn't lie on circle, so the y has to be non-zero, right? So in this case, what you get? Lambda is 2. Oh, well. So lambda is 2, right? And if y is 0, in that case, similarly, you will get lambda has to be 1. So meaning points, the possible points of local maxima, minima are 0 comma y, where y lies on, so sorry, where this point lies on circle, meaning y square equal to 1, and x comma 0, where x square plus y square, which is 0, equal to 1. So meaning what all points you have, these are all the points. 0 comma 1 plus 1, 0 comma minus 1, and 1 comma 0 minus 1 comma 0. And you had already 0 comma 0. Now what you have to do? You have to find the global maxima minima kind of things, right? So you have to evaluate it each. Oh my god. Yeah. Yeah, this is the my keyboard. I have to place my things better. So keyboard I should have here, and my mobile I should have here to see the problems. I have the photocopy of a problem. So yeah. So what is f of 0 comma 1? You can calculate it. I forgot the function. I think it is 2. F of 0 comma minus 1 is again 2. F of 0 comma 0 is 0. F of 1 comma 0 is 1, which is same as f of minus 1 comma 0 for your given function. And so you see 0 comma 1 and 0 comma minus 1 are point of maxima. And what is the minimum? 0 comma 0 is point of global maxima, and global minima I'm saying is point of global minima. Those are local, which 1 comma 1 comma 0 and minus 1 comma 0 are local point of minima. But on the disk we have to evaluate. So we are talking about always global. Okay, I hope this problem is clear. So Lagrange multipliers does sometimes, it make things easy. Okay, very nice. Now, similar to this, you have then this problem number 7. So you have given fxy equal to x cube plus 3y square, and you have given this gxy, you can define it to be xy plus 4. Subject to this constant g, you have to maximize or minimize or whatever to do you have to do with f. So again, you will solve this equation. You see, it's the same tricks. So 3x square, comma, what is this? 3 into 2, 6y should be lambda times yx. So you will get 3x square equal to lambda y, okay, and 6y equal to lambda x. Now let's see how you will do. Note that this point should be on G always, right? Meaning point should satisfy x equal to 2 minus 4. Okay. So what you can do is you multiply these equations. I mean, anyway you can do, maybe not multiply, you find the values directly. So what is your y, guys, from the first equation? 3x square by lambda. You substitute it in second. So 6 by lambda is equals to lambda x, right? So what you have here is, so 6 into 3, 18 x square equal to lambda square. I'm assuming here lambda is non-zero. Okay? We will figure out when lambda is 0 what we have to do. Okay? We'll see if it is even possible. So let's see. So if lambda is 0, this will imply 3x square is 0, 6y is 0, meaning x comma y is equals to 0 comma 0. Yeah, it's a possible point where we should discuss, right? Otherwise, yeah. Otherwise, what we have to do? So this thing. So 18x square is lambda square x, right? So what you will get here from x, you can take common. 18x minus lambda square is equals to 0. So this implies x is 0, or this weird thing, x is equals to lambda square by 18. So if x is 0, guys, y is also 0. And if x is lambda square by 18, then your what is your y? Then y is mm, 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 lambda, oh, to the power 4. My god, weird calculation. So 3 by 18 into 18 into lambda. So you can eliminate lambda. So this is 3 lambda cube by 18 into 18, whatever that is. So 6 you can cancel. So lambda 6 into 18. So whatever this weird number is. What is it? 6 into 8. I'm horrible at calculation. So 8 into 5 is 40, right? So huh? Yeah. 8 into 5 is 40. Then it's 48. So 108. So these are all possible, points you have. I'm covering 0 comma 0 also here. If lambda is 0, then your point is 0 comma 0. So at this point, you have to judge the function. What is a function? F x comma y is x cube plus 3y square. So which is, if you substitute, my god. So lambda to the power 2 into 3, 6 divided by whatever this is, 18 cube plus 3 into 108 square, my god, into what? Square you are doing, again lambda to the power 6. We have to we have to solve this, weird expression. Um, so let me call it some number alpha lambda to the power 6. You know that alpha is always bigger than 0, right? It's a bigger than 0 number. Well, this function becomes in this term, right? If we evaluate at x comma y equal to this point, right? Now, in other words, you just have to maximize or minimize this function. So call, say, capital F. X is, or lambda, is alpha lambda to the power 6. I think you know the graph of this, right? So you can do the further analysis, right? This is a function of one variable where you can, study the point of local minima, local maxima, and all such sort of things, right? Okay, good. So, any other point you are getting? So, these are the points. Let me see. By the way, have we checked that this point should lie on what? X5, x into y should be minus 4, right? This we haven't checked, right? So these kind of points you will get, and this condition is remaining, right? So what will x into y equal to minus 4 will give you? You have here x and y, right? Just multiply these equations. So this will give you some weird curve, right? Let me see what curve you will have. I don't want to do, much of calculations. Or how you can do is, yeah. So if you see 3x squared by y will be equal to 6y by x, right? And this will implies 3x square x cube is equals to 6y square, right? So this will implies x cube is equals to 2y square. So this is the probability case which we haven't explored. And x into y is what? Minus 4. So if you assume your y to be non-zero, then x equal to minus 4 by y. So just substitute it here. So what you will get is minus 4, 4 for the 16, 16 into 4, I don't know what it is. 6 4 is 24, 4 is 4, 64. So what you will get is minus 64 divided by y cube is equals to 2y square, right? I'm changing everything in terms of, yeah, 2y square. So what you get from here is, shall I do it somewhere now? So what you get from here is 64 by y cube, yeah, minus 64 by y cube 2y square. So this will implies, so 32, right? Minus 32 equal to y to the power 5. So this will implies y is equals to minus 2. Well, this is also a point, right? This we haven't exploited, right? And this lambda, whenever, this point into this thing is equals to minus 4. So there also, you can find the value of lambda. So it's one or the other way you want to do. So what is this? Y equal to minus 2. And when y is equals to minus 2, then you can figure out what is your x. So x cube is 2 into y square. So x cube is 2 into y square. And for this function, by the way, if you take such lambda, if one will go to infinity, one will go to minus infinity, right? The graph of this is like this. So there is no point of maxima or minima which we can obtain from here. So what is x cube equal to 2y cube? Y square. So this will give you x cube is equals to 2 into 2 into 2. So x is equals to 2, right? So you have another point 2 comma minus 2, and see what is the value of function at this point. So the value of function at this point is, what of the function I forgot, so I think 2 cube plus 3 minus 2 square. So this is something bigger than 0. But you have seen there are possible lambdas where I haven't computed that particular lambda, but where the function can goes down to infinity. So what you will get, this 2 comma minus 2 is point of maximum, right? That's all you have to do. Hmm. Point of maxima. Oh no, no, it's not a point. Yeah, yeah, it's fine. Local maxima I'm writing. It's a point of maybe not. Just we can say extrema only. We don't know what actually the behavior of the whole function would be. So better to call it just point of extrema. Anyway, the question asks you to find the point of extrema. So what is the next problem? So see, this is on the same level, I mean, rest all problems are actually same. So maybe we can do one more. I'm not doing this last problem, this mountain and all. So let me do maybe this one, 8. So alpha, beta, and gamma are interior angles of triangle, and you have to find the maximum value of sine alpha, sine beta, sine gamma. Oh my God, this is too calculative. Not too calculative. So what you have given? These are interior angles, and you know interior angles sum up to pi. So that is what your G will be: alpha, beta, gamma, alpha plus beta plus gamma minus pi, right? And what will be your f of gradient of f into lambda of gradient of G will give you? You have to differentiate it with respect to alpha. So it will be cos alpha, sine beta, sine gamma, and then you will have, you know, sine alpha as it is, cos beta, sine gamma, and then you will have, my God, I just don't like calculations, and that is the course of calculus. So yeah, I should not complain. So this will be lambda into 1, 1, 1, 1, 1, right? That's what the, the partial derivative will look like. Let me check. Right? Now, what you can do is, so you have cos alpha sine beta sine gamma is equals to lambda, and this is also equal to, you know, uh, sine alpha cos beta sine gamma. And this is also equal to sine alpha sine beta cos gamma. So this sine and cos are very, tricky functions because they are not always 1, 1 or on 2 because the graph oscillates. But if you see, call this 1, 2, 3. So all are equal, right? So if you divide 1 by, say, 2, so what you get, guys? Or 2 by 1. What you get is tan alpha, right? And if you divide, say, yeah, 3 by 2, what you get is tan beta. Whenever it is possible. I mean, you are not allowing them to be zero. When you are dividing, you have to have the case that those are non-zero. So this will implies tan alpha equal to tan beta, right? And maybe see, your angles sum up to, pi. So can any one of these angle bigger than 2 pi? Right? It is not possible. So your angles are always, lying between 0 to pi, of course. Then what you can say from here? On 0 to pi. So if you see the graph of tan, so this is pi by 2, and this is, say, pi. Here it goes like this, and here it comes like, something like this, yeah. And here it goes like, how to draw, let me just see. So this will be like this, right? This is the graph of tan on this region 0 to pi. And on this region tan is 1, 1, right? So alpha has to be beta. Correct? So now, this is one. So we have divide 2 by 1. So can you do another possible thing? Say beta and gamma I'm interested in. So if you take, say, mm, I don't know what. So if you divide, say 2 by 1, no, that we already done. 3 by 1. You get something different? Yeah, you get tan or maybe 1 by 3. So you get 1 by 3, you get tan of gamma, and then I need one more equation in gamma or beta. Yeah, I'm not very great at these things. So 2 by 3 if you do, what you will get? Yeah, 3 by 2. Let's do 3 by 2. You will get 10 beta. Oh, now, yeah. Now with the same logics, what we have done above, these all are equal, right? Why? Because these are all 1, 1, 1, because all are equal to lambda. So this means this is equal. So tan equal to tan beta. This will implies gamma is same as beta. So alpha, beta, gamma are same, right? So what will be your yeah, alpha, beta, gamma? So this is what you have, right? And also you have this thing, right? Tan of gamma is 1. So what should be your gamma? It is lying between 0 and pi by 2. When tan takes value this 1, can it take 1? Or see, this will happen or not. That's what you have to see. So rather than what you can do is, mm, you can see, yeah, tan does take value 1, right? On pi by 4, right? Or you have alpha equal to beta equal to gamma. Oh yeah, you have alpha equal to beta equal to gamma, right? And what they satisfy? They satisfy this equation, right? So what you will have? 3 alpha equal to pi. So this implies alpha equal to pi by 3. Oh yeah, well, this is what you have. So now, once you have alpha equal to pi by 3, you have the point here, right? Pi by 3, comma pi by 3, comma pi by 3. This is the point of extrema. That's what you have to do. Mm, yeah. So I'm sorry, I'm a bit slow at these things. It's very calculative. If you have seen, I was very quick at proving that thing, this result. So I think this would be good. And thank you very much, guys.